Thanks, Blake. My name is Brian Webster. I'd like to walk through a couple of demonstrations today of how organizations can take advantage of different strategies when migrating security controls to the cloud. We've just heard about the importance of ensuring that we grab the correct security controls and make sure that they're along with us on the journey to our cloud migration. But personally, I find that the greater challenge often in a move is less about ensuring that controls go with me or that all my belongings go with me. And oftentimes, the greater challenge is understanding where to put those belongings when I get where I'm going. Sometimes the destination is really easy. Beds go in a bedroom, but sometimes it's not as easy as I might think. The spare TV, does that go in the spare bedroom? Does it go in the kitchen? Let's drop the metaphor and get to something a little more concrete. This is a very typical perimeter defense scenario for a data center. We have a perimeter firewall. It's blocking access from the internet into protected systems while allowing access between trusted zones. Public cloud providers have gotten a lot better in the last several years about enabling this type of topology for public cloud environments. And we can see an example here using AWS's Transit Gateway to allow access through an egress VPC to the internet from protected VPCs while still controlling access between those VPCs. It's really interesting to enable this topology, but as you can see, there can be some challenges in terms of configuring the infrastructure and ensuring that all of my connectivity works as expected. I want to take a look at this example in Cloud One Network Security. You can see here that I've already added an AWS account to my console, which will enable visibility and inspection of the cloud account and hopefully simplify our deployment. Next, I'm going to go and look at the deployment topology for this infrastructure. I'm going to select the cloud account that we just viewed, and I'm going to move through the wizard, which is going to prompt me with a list of VPCs in my infrastructure. I'm going to select this perimeter gateway VPC, and Network Security Console is going to interrogate the cloud provider's APIs to determine whether or not this VPC has been properly configured. If I've done my job correctly, it's going to provide me with a link to be able to download a CloudFormation template. This template has been purpose-built for my infrastructure to enable seamless deployment of protection with a network IPS inline in this egress VPC. I'm going to download that template. I'm going to take it over to the public cloud provider's console where I'll upload the file. Then I'll move through the wizard. I've got a couple of little things to enter, just a name for the template, and then a couple of checkboxes that will allow the CloudFormation service to deploy the template as it's been built. This is really engaging for a number of reasons. One is we need very, very little information about the deployment itself in order to be able to execute this installation. The second reason is that this enables the CloudFormation console to deploy resources exactly as they're designed and exactly for this infrastructure. We can see here, when I move back to the Network Security Console, that not only has all of my infrastructure been deployed, but additionally, the IPS has already been registered back to the console. It's online, it's up to date, and ready to provide inspection for my traffic. This is one really easy example of being able to deploy inline inspection for a range of VPCs. But sometimes VPCs aren't all created equal. We'll see smaller VPCs, we'll see larger VPCs, and we might see a large number of VPCs in varying configurations. Especially in organizations who are executing a migration strategy with velocity, it may not be ideal to have a network team come on board, configure all of my cloud topology to be able to support aggregated inspection points or like an egress VPC. Instead, it may enable greater speed of transition to allow individual application teams the capability to deploy that inspection for themselves. Let's have a look at what that might be like. Back in the Network Security Console here, we had my original AWS account loaded. What I'm going to do now is walk through the process of adding another AWS account. I've already completed all of this configuration in the account side. But for background, what's happening here is the console is walking you through everything that's necessary to create the role, permissions, and policy for network security to inspect the AWS account and help with deployments. Since I've completed that already, I'm just going to drop my role ARN here in the console, and we'll keep moving through. Going to name the account, just something to give me visibility to it. And now this account will be visible in the network security console. For a little bit different take this time, instead of deploying network security with the custom CloudFormation template generated in the console, we're going to go to a capability called Aws Service Catalog. You can see here that we've deployed a portfolio of Cloud One capabilities into this AWS account that allow individual application teams to onboard security capabilities quickly and easily with very little required knowledge of the underlying infrastructure or interaction with security teams who want to monitor those capabilities and manage risk for the organization. We walk through here, you can see we have exactly one item to enter, an API key, which could be handed off to the application team from the security team, or could be generated programmatically and delivered through code. What's happening behind the scenes in Service Catalog here is actually almost identical to what we did in the previous step with CloudFormation. But instead of having one custom template for one egress VPC, what we've done here is standardize a set of capabilities that application teams can self-service and deliver on their own. When we take this back to go look at the network security console, we can see the same result. We have a new IPS, which is registered back to the console. It needs to be updated, have its policy distributed, and it's ready for the security team to enforce policy and enable protection. The other advantage of this type of integration with the public cloud providers is to give us a way to determine what is being protected and what may have issues. We can see in this example that we have a number of VPCs that are not yet protected, and maybe they can take advantage of the same capability we've just demonstrated on this first application account. So we've got an egress scenario, we've got a distributed application team scenario, but those were pretty simple VPCs. And I seem to remember discussing more than just network security controls. How do we take the rest of our capabilities with us to an environment, but still enable this type of autonomy and this division between organizations or alignment that enables application teams and the migration itself to move quickly? Sometimes we might have VPCs that look significantly more complex. Deploying an inline IPS with centralized visibility could be more challenging in this environment, especially if the networking is strictly managed by the application team who's responsible for delivery of the value to customers in this account. Let's move now from the network security console to the workload security console. It's near seamless to move from one platform to the other, where we have the same type of visibility into resources that are available for protection. But now we'll be looking at a different form factor for deployment. The first step for most organizations that I work with in a migration is to automate absolutely everything. So what we're doing here is we're grabbing a deployment script from the Workload Security Console. This is a little bit of Bash for Linux or PowerShell for Windows that will enable us to activate an agent after it's installed, to assign a policy, and to be able to deliver that into nearly any environment. For a first example, let's take something really quick and easy. We're just going to go launch a new EC2 instance, and we're going to use a capability in AWS called user data to deliver some instructions for the instance to customize its behavior after it's launched. What we're going to do is we're just going to scroll down, drop our deployment script into that field, and once the instance is done launching, we'll be able to see that protection activated. Now, I certainly don't expect many teams will be using this for any type of mass management of systems, but it is very handy for demonstrating a way that we can take this automation and deliver it into any environment. For a second example, let's look at something maybe a little bit more robust. Here we have Aws Systems Manager. This is a collection of capabilities for managing software and deployment in AWS. We're going to have a look at a capability in Systems Manager called Distributor. This is a way for organizations to deploy their own, or in some cases, third-party packages, which are built to automate deployments and manage lifecycle. We're going to grab the Trend Micro Cloud One Workload security package that's available as a third-party provider in the console here. What we're going to do is we're just going to name this deployment. We're going to add just a couple of qualifications about how I want this package to be deployed. In this case, I want to ensure that every test system that gets spun up has a deep security agent activated and offering protection. So we're going to use the tag to set the parameters by which Distributor will know when to install our system. These are just two examples, but we've seen organizations use strategies from CloudFormation to Terraform to third-party system package managers. The key here is really to enable flexibility of choice so that builders can use the technologies they're already using to deliver your security capabilities as well. I want to flip back now. We're going to do a little bit of movie magic so we can see this change over time. But I wanted to give an example of how a typical public cloud environment changes and dynamically creates, activates, terminates instances, and how it can be really important to ensure that this automation is in place to deliver risk management over time and in the least friction way possible for application teams. This has been really fun for me. I'm almost out of time, so I do want to leave you with just a couple of final thoughts. We heard from Blake really important insights into how choosing the correct security controls is critical to success of a cloud migration. But I really want to leave you with a little additional thought that part of finding that right tool is ensuring you have the right fit for deploying the tool. So as you walk through your cloud migration strategies, I'd urge you to keep focus for alignment between the strategy for application migration and the strategy for the security migration at the same time. Consider which teams are actively running these migrations and whether it's natural for them to have their existing responsibilities, or in some cases may need a little bit of shift in roles and ownership in order to deliver on the promise of a public cloud migration. And lastly, one of the biggest keys for me is to ensure you're designing security control selection and deployment with the greatest flexibility for fit and to reduce friction for our teams to be able to continue to provide value for their customers and help realize the benefits that are hoped for from a cloud migration. That's it for me. Thanks so much. I hope you're enjoying Perspectives and have a good day.